The Marine Toys for Tots foster care program is bringing hope to children who need it most. Every 2 minutes, a child enters foster care, often with only a small bag of belongings. More than 400,000 children face trauma and uncertainty, many before age 8. This May, during Foster Care Awareness Month, Toys for Tots is creating Room for Joy. In 2025, nearly 375,000 children received comfort through toys, books, and essentials, reminding them they are not alone. Donate now and change a child's life.
This is the Dr. Sky Experience. Always look to the sky. 77 WABC. Now, here's Dr. Sky.
A tribute to my mother Dolores, otherwise known as Mama Sky. Born in 1931 in Flatbush, Brooklyn, and to all mothers around the world, I'm sure we can agree, I'll always love my mama.
Oh, yes. I was born in 1931 in Flatbush, Brooklyn. Thank God I have my happy memories of Coney Island, Flatbush, and all that. When I heard your voice, I said, I'm listening to this show.
I'll always love my mama. She's my favorite girl.
Happy Mother's Day to all mothers around the nation and the world as we continue here, ladies and gentlemen, talking with Nobel laureate Dr. John Mather. He's a NASA scientist, and he's here with us through the entire 2 hours of the radio show. But an apropos quote from Albert Einstein goes something like this: God does not play dice with the universe. Doctor, welcome back. That's fascinating. Because when we talk about the whole Nobel Prize story, that's amazing. There have been so many scientists that have won that, but let's go back to Albert Einstein in 1921. I mean, that's fascinating when he was in Bern, Switzerland, as what? I think he was a patent clerk. So imagine if you walked into the office and said you wanted to patent something. In his spare time, he was working on things that are what? Otherworldly. And exactly, if you could tell us, what was his Nobel Prize for back then? If you could shed light on that.
Well, actually, he did 4 Nobel Prize-worthy discoveries in 1905.
Oh.
Just can you imagine 4 discoveries? He discovered relativity. He explained the photoelectric effect. He understood how to measure the size of or the mass of an atom through something called the
like the slit experiment, right? That slit, the slit experiment. Yes.
And there's a if you look at a microscope, you see things jiggling around randomly because they're being hit by random atoms. So it's called Brownian motion, so he figured that out. So a lot of things he did in 1 year. So I actually can't remember which was the one that got him the Nobel Prize. It was not relativity.
Interesting.
People didn't like relativity when he told them about it. They said that it could not be right. And I still have friends who think it can't be right, but it's really hard to escape it. And we've had over a century now to test whether his story is correct, and nobody's actually found a flaw.
That is amazing. And there are those, and if we go back into the history, the great debate that they had, as far as whether he was a real fan of quantum physics at the time. I think if, this could get very deep, and I think the audience needs to understand it from your perspective. He would do thought experiments. But was he really a believer in time like that of the whole quantum concept, or was that kind of alien to him, with all due respect to Dr. Einstein? What would you say, Dr.?
Yeah, he was, I think, a founder of the subject. And I think he was correct that a lot of other physicists misinterpreted the story and still do. If he were here today, he would stick with his point that it's not God playing dice, as he would say.
Yes.
It's that we're misinterpreting the whole plan. So there's a lot of controversy in the science world about how to interpret the equations of quantum mechanics. We're not actually arguing about whether the equations are right. We know they're right because they work correctly every time you test them. But there are some very surprising interpretations. And in fact, the Nobel Prize was given just recently for 3 people who showed that the quantum entanglement story is correct.
Amazing.
And one of them was a friend of mine from when I was a graduate student at Berkeley. He was sure that quantum mechanics was wrong, and he set out to prove it. And when he actually made the measurements, quantum mechanics was right. So he wrote it up, and as a result, he got to share in the Nobel Prize for proving that he was himself wrong. It's an amazing story.
Wow. What a story there, Doctor. Let's continue to go to the callers. They've been very patient. Let's say good morning on line number 2 to Alan. Alan in Long Island, good morning. You're on with Dr. John Mather. How are you doing? Thanks for your patience.
Gentlemen, awesome show. And happy Mother's Day to everybody.
Yes.
And the moms and the mothers out there who have broken hearts, it's your day too. Oh, yes, it is. Okay, guys, any kind of an award, a big award in the sciences is unbelievable. I was the PS12 arm wrestling champ, if people wanted to know. But I like to bring up a couple of things. Like, we know the Voyager has been out there for like 50 years now, and it's still in our galaxy to show you how big things are, and probably it's not moving as fast. But the thing is, I like to say is, we have radio transmissions, TV transmissions. Now, if there's something in another universe transmitting those kind of signals too, wouldn't we want to have like sort of like something that could receive it, and they could have something that could receive it? And I also like to say, like, our universe is gigantic. To all of us, we only, in our minds, everything we know comes to an end. So we don't really understand how this universe could keep going on. And I would like to hear from John, what is his opinion of what's out there as you get to the end, if there is an end, or it just keeps going, which we can't fathom. And plus, I like to just say, as a country, we are becoming a third world country. So you're not going to have they're hungry for this kind of information and knowledge and discovery out there as we turn into a third world country. Look at us. We have spaceships. Third worlders, we have to feed them. So that's the big difference. We're turning the country over. Do you feel uncomfortable with that too?
Alan says a lot there, many interesting points. Doctor, I know you're happy to respond on some of those.
Yeah, sure. Well, like I mentioned at the beginning, I've heard about infinity when I was 6 years old. And I thought, this is amazing. Ancient Greeks discovered mathematically that there's obviously no largest number. Because if there were one, you could always add 1 to it, and that would be bigger. So they figured out mathematical infinity. And the world we picture in physics is like that in terms of space. We can't imagine coming to an end of space. We can't imagine that the universe has an age that you can't get past time zero. And maybe you can't even get 2 times 0 in your imagination. But it's still not a hard edge. You can't get there to that edge. So the universe seems to be infinite to us. No boundary that we can recognize or see any sign of. And we do have receivers trying to pick up signals from everywhere out there. So far, by the way, no obvious sign of intelligence sending us a message. Lots and lots of information about astronomy. Pictures, stories, imagination. I mean, that's how we get to tell you what we found.
Yes, that's quite amazing. Alan, I appreciate you. Thank you so much. Happy Mother's Day to you and your family and all the mothers out there listening here to the Powerhouse Talk Radio 77 WABC. Let's go to line 1. Let's say good morning to Stephen in Manhattan. Stephen, you've been patient. Good morning. Your question or comment?
Good morning, gentlemen. Thank you for accepting my call.
Yes, sir.
Just a couple of items, if I may. And you touched a lot upon that, and you're just in the previous call. I'm very interested that, there's no wall in the universe. There's no stopping. How do you account? How does one account when you get to 100 trillion light years away that there can be another 100 trillion light years? And how would you account for that amount of space? And my other topic I wanted to ask you about is just floating from my mind right now. So,
well, no disrespect. The universe is so mind-boggling. So, there's a lot here on the table. But I think, Stephen, we do have the first part of what your concerns were, Doctor. Your choice and your chance to respond.
Yeah, we think about that a little bit. Well, here's one way you can ask. What shape could the universe have so that it would actually come to come to an end? if there were one. So suppose the universe was circular or spherical in some way, then you could imagine going out some great distance and coming back where you started from. So that would be one way that you would not have an infinite universe. It could be finite. On the other hand, that one that I just described doesn't have an edge either. You can't fall off the Earth. You can't fall off the edge of the universe either, as far as we know. So it's a possibility that the universe is just infinite in all directions. That's the way it looks to us today. And how would you know? And the way that we can try to estimate that is see our lines straight or curved. Here on the surface of the Earth, if you set off with two parallel lines, they will eventually intersect, like two different meridians intersect at the North Pole or the South Pole.
Exactly, so, like a globe. Yeah.
We can try to measure that in the universe, too. And we have indirect ways. And so, as far as we can tell, it is more or less geometrically flat. So two parallel lines neither diverge nor approach each other. So it's geometrically flat. So that's the current estimate that we have. Is it correct?
Totally amazing.
We don't really know, but that's the best story we have.
Totally amazing. And I'm understood here. We're almost up against the next break, Doctor. But very quickly, if you'd be kind enough to respond. Allegedly, as I read in various, different journals and different information sources, not always on the internet, that the universe expanse right now maybe reach out to about 90+ billion light years. So in reference to what Stephen was talking about, maybe a wall or something, not a wall, but is that a fairly accurate number, that outward about 90 billion light years as this thing, if I would describe it, as this expansion bubble, even though it's not? Is that a fair distance? What would you say?
Yeah, honestly, we can't see that far, so we can't really be sure. I think it's a fair guess that there is no wall, that there's no limit. But what we're limited to doing is looking out with light waves. And so we can receive light from distant places, but we receive light that was sent out a long time ago. So by the time we get it, the thing is no longer the same as it was when it sent that information. So we're limited in measuring a pretty small piece of this probably infinite universe.
That's incredible. Doctor, we're up against that break, and we tell that to the listeners ahead of time. We see your calls coming in, and we'll do everything possible to get everybody an equal opportunity to speak their mind and ask their questions, as long as we stay on measure with the topics. We covered UFOs and that whole situation, and we'll do that again. But in respect to the good doctor, with the time limited, we'd like to continue on those. And we do a little sky report also, Doctor, here for the people who always tune in to wonder what's happening in the visual side of astronomy. So if you go out, ladies and gentlemen, you have clear skies. The moon reaches its last quarter phase. Obviously, it's waning, so it's shrinking each night. And then it moves on to its new phase as we come on by the 16th or so of the month. The best time, in my opinion, to see some of the amazing dark things in the sky, in dark skies, I should say. Jupiter overhead, or nearly overhead at sunset. Venus, the brightest object in the northwest. And those objects will coalesce to come together in June, a magnificent conjunction of the goddess of love and beauty and the god Zeus, Jupiter, in our northwest skies. More with our special guest, Nobel laureate Dr. John Mather, and your questions and comments on the Dr. Sky Experience.
This is the Dr. Sky Experience. Always look to the sky. 77 WABC. Now, here's Dr. Sky.
Hi, it's KC from KC and the Sunshine Band. You're listening to Dr. Sky Experience on 77 WABC. Get up and shake your booty, because that's the way I like it.
Not only does God play dice, but he sometimes throws them where they cannot be seen. A quote from the late great cosmologist and astronomical genius, Stephen Hawking. As we continue, 46 minutes after the hour, our special guest, and continuing into hour number 2, Nobel laureate Dr. John Mather. He is a current NASA scientist, so much to talk about, and so limited time. But let's just get to many of the callers as we possibly can. We say good morning on line number 2 to Alice in Ohio. Alice, thank you. Happy Mother's Day to you.
Thank you very much. A quick question. I recently went into astronomy, and I'm still learning. So this is just a request. If you could plan a program, a lot of this is over my pay grade, but for those of us who are just entering the interest, and I belong to the Cincinnati Observatory, and we have wonderful lectures and evenings. Just a quick question, and you touch on my favorite subject, aviation and astronomy, and I appreciate your show. I make it a point to stay up every weekend to listen to.
Wow. That's very powerful stuff, Alice, and I appreciate you. You know, we talk about this, Doctor, that many people want. You could recommend different clubs, like Alice, the caller, is saying here. She's our guest, that she belongs to the organization there, an astronomy observatory. And it also starts in the schools, right, Doctor? STEM and STEAM education. Any other advice you would give for people who are fascinated but may not have to have a PhD or, with all due respect, be a Nobel Prize recipient? They have to start somewhere, right?
Well, yeah, everyone starts somewhere, and the key to being a scientist or to enjoying life is curiosity. I just want to know how the world works. I want to know how my friends are. How do they feel? How do they think? How do they come to think what they think? What's going on here? And I just think it's fascinating to find out. So turn over those rocks, see what's living under the rock. Look out in the sky at night, see what's up there. See if you can see it. There are a lot of things you can see with your eyes that are quite beautiful. With your binoculars, you can see the satellites of Jupiter that Galileo discovered. Yeah. And see them go around. There are different places every night. So there's so much you can recognize just to enjoy the process of discovery.
It's amazing. We go to line number 3 on the Theater of the Mind, welcoming Bob in Riverhead, New York. Thanks for joining us. A rare opportunity to speak to a gentleman who has lots of experience, and the world knows that too. What say you?
Appreciate. Well, if we were to take the departure and arrival points and warp space-time, would the speed of light limitation apply? And what was the seed for the Big Bang? And do we still believe the universe might contract? And is time experienced differently in different planetary gravity wells?
Wow, you brought a lot here to the table, but Doctor, as you see fit to respond.
Yeah, I'm not quite. I can't really answer all of them, but I think one of the great questions that people miss is that the speed of light is a limit on how fast anything can go locally. If I'm passing you on the sidewalk, I can't go faster than a certain speed relative to you. But places that are separate can actually recede from each other at faster than the speed of light because this is space itself expanding. So that's different. Mm-hmm. So Einstein figured them both out.
It's amazing stuff. Yeah, the mysteries that we talk about here, and it's enlightening to have you here, Doctor, to listen to the questions and respond, because we really don't know. I mean, as we continue to open our minds on this, the human brain has got only so much capacity, and now with AI intercessions in here, who knows what the things that we'll be discovering. But Bob in Riverhead, New York, thank you for being part of the Dr. Sky experience. Moving through time and space, apropos and very well said. Moving line number 5, we say good morning to Pete in Staten Island. Pete, how are you doing this morning?
Hey, Dr. Sky, and your guest. It's been a very interesting show. I got an idea I want to run by you. I'm usually a guy that changes topics, but this time I think I'll be on the right topic. Okay. I'm talking about these electric cars. When do you think they would come up with an idea to have like solar panels on it to recharge it? Or I bought a house and they had an old bike in it that had the old thing that was on the wheel that as the bike would turn, your lights on the bike would light up. But is there any way that they could make a mechanism that could go in these electric cars that could charge while the car is driving? You know, like one of those things with technology. I don't know these things. I'm 70. The idea would be great that the car could recharge itself with one of those things on a bigger scale, you know, something that would make enough juice, you know, while the car is running. Because I have a friend of mine's got one. and he drives car service. He's got Uber, and he spends more time getting the car charged than he does actually driving. I mean,
that's right. They're all limited. Right.
You get about 200 miles to a charge,
yes.
And when it's cold out, you only get about 140, which really stinks. But
Pete, let me go back before the good doctor answers here, because I think there's another source, and he's better qualified than I am to talk about this. The number one available element in the universe is hydrogen. So if we could develop, and they have had hydrogen cars, but doctor, what would you say? Imagine hydrogen propulsion. It seems to be everywhere in the universe. And how would you respond back to Pete?
Yeah, well, his first question is about charging. Right. And sunshine actually comes from the nuclear reactor in the sky, the sunshine. It's a great, very controlled nuclear reactor up there. But unfortunately, there's not enough of it in the amount of solar panels that you can put on your car to keep it charged. So you just need bigger panels than you can put on your car. So you need your house or something to charge it from. As to hydrogen as a fuel, it's a perfect fuel. And when you burn it, you just get water. So that's non-polluting. The hard problem is getting the hydrogen in the first place. So how we probably do it in the future is either from capturing sunshine and using the heat, or there's also just the traditional electrolysis, where you use electricity to get the hydrogen apart from the oxygen in the water. Both can work.
Amazing.
It's tricky, but it's possible.
Well, we appreciate it.
And it's already done. You can buy those kinds of cars if you really want to.
Yes. They're out there. I mean, we see them here. I'm in Arizona, but we see them. But unfortunately, the fueling of that, there was a couple of models of certain manufacturers' cars. I don't want to name them. They started off good, but the unavailability of the refueling stations kind of killed that idea for now. But hydrogen, as you know, Doctor, the most abundant element in the universe. Line number 4 as we close out hour number 1. And if we don't get to you, like Mark in Manhattan and Helena, and I hope I pronounce your name right, in Westchester, please stay on the line with us as we go into hour number 2. Let's go to line number 4 and say good morning to Frank in the Bronx. You're on the air with Dr. John Mather.
Hey, Dr. Scott. Hi, John Mather, Dr. So I want to say something about the Big Bang and the expansion of the universe. In quantum mechanics, a lot of times our brain don't understand, don't comprehend. Like, something can come from nothing, because nothing is not nothing. We have a box. We open an empty box. That's not nothing. That's not nothing. But in quantum mechanics, we don't understand. We can't comprehend. That's what my thoughts are. And also, if we do understand that, and really get, I think we could travel faster in life. There'd be another way to travel.
I'm open to those possibilities. Doctor, I think Frank brings up something very interesting. How do we move to possibly speed beyond light?
Yes. So a lot of people have said, well, something comes out of nothing, but we don't have any equations of physics that say that. We only have equations that say something turns into something else. So something coming out of nothing is a little bit misleading as a description of what they. So I'm sorry that people say that, because it's misleading to you. So we can use energy to produce particles, and so we do. It happens a lot, all the time. But that's not producing something out of nothing. It's producing something out of something different.
Amazing. The mystery goes on. That's incredible. Frank in the Bronx, always appreciate your commentary and questions, as we do all of the folks that are calling in here. And as I mentioned before, time doesn't permit it for this hour, but Mark in Manhattan, please stay on the line, and Helena, hope I pronounce it right, in Westchester, we'll get to you and many, many other questions that we want to have answered by our very special guest, Nobel Laureate Dr. John C. Mather, joining us in hour number 2. And we're going to ask him in hour number 2, describe this later, Doctor. I mean, this is interesting. It's a story unto itself. You and your team are working very hard in the science world. You write the theses. You write, again, all these different research papers. And George Smoot, the co-recipient with you with the Nobel Prize in Physics for 2006, we'll hear in hour number 2. Describe that from the humanistic side. One day you get a phone call or you get a telegram, if that's the old way. you get an email and somebody tells you you're going to be listed as one of the recipients. That must be an exciting story. And we definitely will hear much more about that. And this is the other part I want you to identify before the clock runs out. Tell us briefly your involvement with the James Webb Telescope. What was your role there? Because we're going to have a ton of questions about that. One of the most incredible pieces of space technology. What was your involvement with James Webb?
I was the head scientist of that project for 28 years, from the time that we formally decided to do it to a little after lunch, and now it's handed over to other people to run it, and they're doing it beautifully.
Yes, that's amazing. What an incredible machine, and we get into that in hour number 2. I mean, that's just so incredible, Doctor. I've got books all over my office here from people, many, many other authors, good people, and it's so amazing how that whole piece of equipment, it was like what? It was like a transformer, for those out there that know what the transformers are, something that doesn't look necessarily like a spacecraft. It's folded flat, and then what? It opens up through time out in space, moving out to a point of what? About 930,000 miles from the Earth. That alone is just incredible. I mean, kudos to you and your team, and we'll talk so much more about that. And as always, my email. If you have an email for me, it's drsky@wabcradio.com. A source, and I respond to all of those emails, and thank you for them, ladies and gentlemen. Potential guests come from there, not always a guarantee that we'll get them all. But as long as we stay within those realms of astronomy, space, aviation, and weather, we do pick up celebrity guests, as you hear some of the promotions here. We like to talk about celebrities, and we also love to talk about stories of American exceptionalism as we move to the 250th anniversary of the United States of America. And so much more when we come back here, 1-800-848-9222. And I say it once and I'll say it twice. Why not download the WABC app if you haven't done that by now? What a convenience it is, because many people tell me, hey, I'm glad I downloaded it because now I have access to all the stuff from A to Z. I don't have to keep going back into my computer to reload everything. Well, hour number 1, Doctor. That went fast through time and space, so thank you for your time. I know it's early for you in the morning. We will be right back for an exciting hour number 2 with Nobel laureate Dr. John Mather, a NASA scientist, and so much more, talking about what the experience of a Nobel Prize is like when you hear that amazing award, and also his involvement with the incredible machine, the James Webb Telescope. We'll be right back.
Always look to the sky. The Dr. Sky Experience is on the air. 77 WABC. Now, here's Dr. Sky.
I'm looking down the glowing barrel of a microphone, attesting to the blowtorch signal of, yes, Talk Radio 77 WABC, as we say Happy Mother's Day to mothers around the world, and of course, who knows, maybe even out into the cosmos. The contact number is always 1-800-848-9222. And if you're continuing to join us, and if now you're joining us for the first time, welcome to the Dr. Sky Experience, a show which we call, what we like to say, Theater of the Mind. Why do we say that? Because obviously we're not seeing the visual images, but in our minds, the great stories of radio in the past, this is a family of Theater of the Mind. We talk about the great realms of astronomy, space, aviation, weather, celebrity guests, as you hear many of their promos, very interesting stories, and stories of American exceptionalism as we move to the 250th anniversary of the United States of America. Continuing with us is Nobel laureate Dr. John Mather. He has many things to say, ladies and gentlemen, not only his involvement with the James Webb Telescope, but let's continue, Doctor. Thank you for staying with us. What's the human side of the Nobel Prize? I mean, describe how this came to you. What a surprise, right? Or did you ever think in your wildest dreams that you would be the recipient of this? There's a lot of competition in that world in science. Tell us how that came to you.
Yeah, well, sure. How it comes is you get a phone call from Stockholm at about 5:15 in the Eastern time zone, and October, and so it's everyone knows if you're paying attention what day they might call. But I just said I'm not going to worry about that. So it's a surprise when it comes, at least for me. So it's a pleasant surprise. And then they want to know, are you the right person? Because they don't want to do this to the wrong person.
Exactly.
And you stay on the phone for a little while, and then you do that, and then you hang up, and then the phone starts to ring and ring and ring and ring and ring and ring.
Amazing.
And about an hour later, the newspaper photographers are at your front doorstep, and neighbors have put up balloons, and it's a great celebration beginning. So that's how it goes at the start. Then you go a little longer, and you go to Stockholm, and you have 10 days of parties and speeches, and you get your prize from the King of Sweden.
Wow, that is amazing. I mean, it's probably one of the most highly sought. I mean, other than the Medal of Freedom here in the United States, there is no higher award then, right, in the sciences, started by, as we described before, the man who discovered, of all things, dynamite. That's incredible. Alfred Nobel, back in 1867. So, again, congratulations to you and also the co-recipient, Dr. George Smoot. Tell us a little bit about him before we go to the callers, because so much to talk about, and we don't want to shy away from the people calling in.
Yeah, well, he's was at University of California, Berkeley, doing his bit while we were leading the mission from NASA Goddard Space Flight Center in Maryland. So we elected him to be in charge of one of the three instruments. So that was his job to make sure that happened. So it was always a little tricky to do that because he was far away from the team. But anyway, interesting guy.
Yes,
creative
amazing stuff. So many scientists, and we talk about the legacy as we continue here. But the only person I'm reading this that rejected a Nobel Prize was during the Vietnam War. Le Duc Tho obviously was a co-recipient, I guess, with Henry Kissinger. And the Vietnamese side of the equation said that because the peace treaty wasn't lasting at the time, he chose not to accept that particular award. That's an interesting bit of history, and we talk about that as Theodore Roosevelt, for the second time, the first American to win a Nobel Prize in 1906. Amazing stories, Doctor. The phone lines rule here. Let's continue with our callers. We hope Mark in Manhattan is with us. You've been patient. Good morning. You're on with Dr. Mather.
Good morning. This may be something of a nostalgia reunion, Dr. Mather. I was a teenager working at Goddard Institute for Space Study on 112th and Broadway. And I worked for somebody who you may have remembered the name of, Paul Schneck. He was the head of all computation for NASA. I'm sorry?
Yep.
Barney Wolf, Robert Spinelli in the physics department, Judy Gagosian.
Wow.
Our director was Robert Jastrow. And I learned of your winning the Nobel Prize from Paul Schneck because I've been in touch with him. He's now nearly 90, and he is a genius of the computer era of the first order. He also told me of your co-winner in later years, John Clauser. I've been in touch with John Clauser also.
Wow, what an all-star family here. This is incredible, Mark. Wow. So the good doctor, you do know some of these people, you're saying?
Yes, indeed. And just to fill in the story, I was working at the Goddard Institute there in New York from 1974 to 1976, and that is where we started the proposal for the Cosmic Background Explorer, which is the equipment that won us the Nobel Prize. So I was 2 years a Manhattanite, and it was wonderful.
Wow. See, right here, the power of the signal. WABC, New York. Listen to all these stories. Mark, that's amazing, and I appreciate you sharing that story. You have a question, though, that you want to jump in on? You got the opportunity.
Well, I just wanted to tell Dr. Mather, number one, Carl Sagan was my mother's cousin, by chance.
Wow.
And also, I was a little adolescent kid in a class that Paul Schneck offered on theoretical computability. And without my knowing it, he had me programming all the systems programming in BAL, Basic Assembly Language, for the two Voyagers.
Totally amazing. Wow. It's amazing.
Well, congratulations. That is a lovely accomplishment, and especially since you were just a youngster and you didn't even know it was happening.
I was 16 when he hired me, and I turned 17 that summer of 1967. And I continued working there for a long time, and nervously sat while we were not sat. I was standing on my toes when we were landing on the moon in summer of '69. Wow. And Paul Schneck told me with great pride. He said, "You were there as a youngster when John Mather and John Clauser were doing their journeyman work in early studies, and both of you deserve tremendous praise."
Well, thank you, Mark, in Manhattan. Appreciate your reminiscing with us. Doctor, that's nice to hear, of course. This is amazing. Your legacy and everybody who was part of the teams. Maybe they didn't win a Nobel Prize, but look, many of the parts make up the total. So there you go. Thanks, Mark, in Manhattan. Appreciate your time with us. Have a wonderful weekend and a happy Mother's Day with your family. Let's go to line number 2. Hopefully I pronounce it. Is it Helena or Helena? Either way, in Westchester County. Good morning. You're on with Dr. John Mather. Thanks for waiting.
Oh, hi, guys. Oh, thank you for stimulating my mind. I needed you both so much. Thank you.
There you go.
Okay. I got a maybe weird question, but is quantum physics and thought patterns, vibrational medicine, anything that you could talk to me about? Is that related at all to anything in your line thought?
Oh, my goodness. Just to begin with, everything in life is quantum mechanical. The shape of every molecule and every atom and the way that they interact with each other is all governed by the quantum mechanics of molecules. And so it's hard to say something is quantum and something else is not. So it means that I don't have anything to tell you about medicine. It's too complicated.
Well, he's an honest doctor, so there you go. Everyone has their limitations, but Helena, that's an interesting series of ideas and proposals and concepts you bring up there. That is totally amazing because the quantum world, as the doctor's explaining, this is one of the big areas of research right now. And I wonder, Doctor, and maybe Helena would even want to jump in on this, with AI intercession, can you imagine the things that we'll probably learn? Doctor, what do you say about the intercession with AI in the physics world in the solving of problems?
Well, we're getting there. We're just beginning. There are mathematical tools that you can use to prove mathematical theorems automatically. If you got something that you've already proved, you can prove that it was done correctly. And we're getting to where the tools can start to discover things on their own. So we're not to where we can say, okay, I need Einstein 2.0 to solve the theory of everything, because I've been asking. And the wizards that do the AI says they can't promise that. Sorry. But I think there's no limit that we know of. We just there's such rapid growth of the technology today that we should not be saying it's impossible about anything.
Yes. And imagine that, Doctor. I mean, you know probably so much more about this. Of course, when we talk about the ability to warp space-time in a way other than what Einstein talked about, but imagine being able to utilize that technology for future travel. Because even though, let's say, the galaxy, the Milky Way, 100, maybe 200,000 light years across, I'm being a broad generalist here, you could still travel in the space-time continuum of maybe warping space-time. Who knows? Maybe we could go from A to Z in some incredible speeds, like of the Star Trek and beyond. We have a lot of positive things to think about that. But Helena, thank you. Happy Mother's Day to you. Thanks for staying with us, and thanks for your patience. Amazing stuff, Doctor. Let's go to line number 3. Greg in Michigan, you've been patient. You're on with Dr. John Mather. How you doing out there?
Oh, my God, fantastic. Mr. Positive, everybody. Boom, shakalaka, everybody. Go for your dreams. God, and everyone keep loving Elvis Presley.
Okay. Anything else? Oh, wow. Well, that was an interesting response, don't you think, Doctor? Keep loving Elvis Presley, one of the greatest.
Oh, yes. I did not discover him right away, but I certainly have enjoyed his music very much.
Well, I'm sure, as you know, all that information is still being transmitted out into the deep part of the universe. And if there is intelligent life out there, well, I'm sure they're rocking to some of those great classics. Let's continue on. Line number 4, we go to Robert in North Carolina. You've been patient. Your question and comment to our special guest.
Yes, a couple of comments and a question. Dark matter is spooky action at a distance. Einstein predicted it, but he wasn't sure what it was. But we have detected it now. The James Webb Telescope is fantastic. What a tool to discover things in the universe. And my question is, have we located any dark energy yet? Have we detected any?
Amazing.
Okay, well, neither dark matter nor dark energy has ever turned up in a laboratory. So astronomers are the only ones who can say that they know that it's there. And we only see these on cosmic scales. So it's pretty tricky. We're not having any luck getting it to turn up in the lab, and we don't know if we ever will. So it's a very huge effort by many, many scientists around the world to hunt for it, and so far, nothing. So ask again in 5 or 10 years or a century or two, and we might have a better answer.
Robert, stay with us on this. I want to jump in and kind of a side question here to the doctor. From my understanding of dark matter, and Vera Rubin, of course, as you know, has been so much involved in her lifetime in this study. So could it fairly be said in the simplest way that dark matter is an attractive force that we don't understand in gravity, whereas dark energy might be a repulsive force? Is that too general, or is it fairly on the right track, what I'm just saying?
Yeah, that's mostly right. As far as we can tell, dark matter is like ordinary matter, except it's transparent. Does not interact with anything else except through gravity. So it's a big mystery, and we thought we knew what to look for, and we looked for that, and it did not turn up. So try looking for something else.
Well, the search continues. Robert, you get an opportunity to ask another question. You still have an opportunity to respond here. Go right ahead if you're with us.
Thank you. I'm glad we've detected dark matter's presence indirectly, though. For now,
it's amazing.
Yeah, we're pretty darn sure it's out there because of its gravity. It makes galaxies rotate differently than if it weren't there. It has gravity enough to bend light waves, and we see that way out there. It's got. Anyway, we're pretty darn sure it's there, but we don't know what it is.
Well, Robert, thank you in North Carolina. Happy Mother's Day to you and your family. Appreciate everyone calling the Dr. Sky Experience. Still plenty of time. If you have questions, and we'd like to ask you to stay on measure, we did cover the UFO situation and what's happened with the release from the Trump administration. And again, that's another subject for another time. If we can just stay on measure about the great subjects of the mysteries of the universe, we would appreciate it. The contact number, 1-800-848-9222. Doctor, I promised the audience this, you obviously being so much involved with the James Webb Telescope. Compare it to the Hubble Space Telescope, which is even still, to my mind, a great technological achievement. But your involvement goes back, to the actual design of this particular spacecraft and this telescope. Describe that historical side.
Yeah, back in '95 when I joined the mission, people had already written a book about what they wanted it to do. But when I came in, I started working with engineers to say, well, can we make it a little bigger and a little better? And could we make it so it folds up and is more powerful than what they'd asked for? So we started working with people who knew how to do that. As it turned out, people in the classified world had already been working on folding telescopes, making up a big mirror out of smaller hexagons. So I worked with engineers and managers to find out how to do it. And we started asking people in the aerospace industry to show us how they would. And so I was in on that part, and it was a very exciting time to see the creative forces of our aerospace industry coming to bear on solving an astronomy problem.
Yes. Describe this, if I'm correct. The Hubble has approximately an 8-foot mirror, while the many segmented mirrors of James Webb is over 21 feet. But it's not one singular mirror, in case people don't know this, because it's theater of the mind. It's made up of many Are they hexagonal mirrors that make up the primary?
Yes, indeed. The Hubble telescope mirror is a circle, about 8 feet across, and the Webb telescope is a big hexagon made out of 18 smaller hexagons all nestled closely together. So when it's made out of small pieces, you have to adjust them into place after you launch. So that was our first question. What if it's out of focus after launch? Answer was, we'll put motors on all of the parts so they can be moved into the right place.
Right, not like the Hubble. Right, exactly. When you had optical, inferiority when that whole situation took place. But no, this to me is so mind-boggling. You have this machine, and it's folded like this Lego, device that you can open up. I mean, that to me is just so incredible. So it's launched back, in December, the Christmas day of, 2021, a French rocket.
Yes.
And I understood that the French rocket, the purpose of launching it there, tell me if I'm even on measure, the heavy weight of that needed something launched at an equatorial way so that it obviously had the extra speed of the rotation of the Earth to kind of zoom it back up into space, as opposed if you did it at higher latitudes with the same powerful rocket. So that must have been amazing. But is that right, that the launch near that equatorial region in Guyana, that obviously helped get it up into space on that Ariane 5 a lot easier than other locations to launch?
Yes, that's right. And as it happens, French Guiana is part of France, so they can just ship the rocket from France to France and launch it there. The harder thing was to get our telescope from California to the launch site, and it had to go by barge through the Panama Canal.
Oh, geez, I didn't know that. Wow.
Yeah, it was quite an exciting trip for the people that had to make it happen. Hardly anybody went on the trip because, the telescope is not lonely. It just needs to have the proper care and feeding as it goes.
Yeah, that's amazing. So she launches into space, and it's not just a simple, let's open it up right away. That took, a couple of weeks to get to this point? And describe the point. We call it L2. So the James Webb is about 900, almost 1 million miles away in a stationary point, but everything worked and unfolded as you would have expected. That's totally incredible.
Yeah, of course it's incredible, but it's also the only thing we could possibly do. If you didn't make it work, then you should not be doing it. So, of course, how do you make it work? You test it many times, because you never can get anything right the first time, in case you hadn't noticed. So test and test and test and test and test. We unfolded that thing 4 times before launch.
Amazing.
So you got to do that, otherwise it won't work.
So it's out in the cold of space. The sunlight hits one side of it. And tell us this, because I'm reading this right now, and this is not me just having the knowledge that you have. You have this instrument on one side, there's a temperature, but the instrument module on the other side with this Kapton layers, like this very thin, it almost looks like, in the description I have is like thin aluminum foil, but it's thinner. From one side to the heated side, to the instrument modules, they have to remain at 370 degrees below 0 Fahrenheit. That's incredible if I'm reporting that correctly here for your AOK on. That's amazing.
Yeah, that's about the right number, I think. Usually we use Kelvin numbers because it's good for engineering. But anyway, it's really, really cold. And you should say, well, why is it so cold? We want to pick up infrared light, and we want the telescope not to emit any infrared light. So how do you do that? You make the telescope itself cold.
Amazing. So it sits out in the dark of space, and then it transmits its data and information in record speed? I mean, you're talking seconds away, data transformation?
The information comes on radio waves, which are kind of light waves, and it travels that distance in 5 seconds.
Amazing stuff. Let's continue with the callers. We're lighting it up, Doctor, as I would imagine here, literally moving through time and space. Line number 1, let's say good morning to Ron in Westchester County. You've been patient. Good morning. Your question or comment?
Yes. What exactly is the Nobel Peace Prize? Is it like a statue, a document, or a crown?
Oh, my goodness. Well, all the Nobel Prizes for peace and other subjects are little gold medals. They're about maybe 2 or 2.5 inches in diameter. They're solid gold, very heavy. And they have a picture of Alfred Nobel on one side and something about the specific prize on the other side. So there's no string on it. You do not wear it on your neck. You put it in a display case.
That's amazing. No, in all honor.
There's something more beautiful that comes. So there's a customized artwork that comes along with it.
Wow. So I understand it's made of solid gold. I understand it's 17 grams of gold. So if you do the math, wow, we're looking at maybe $26,000, $27,000 worth of gold. But you deserve that, and you're a co-recipient. That's amazing. Ron, other question or comment before the clock runs out? Go ahead.
Yeah, Dr. Mantis, you want to sell it?
No, I don't think so.
No, it's not like Super Bowl rings that you find in pawn shops. I mean, this is not something, not to be totally ridiculous. You earned it, and obviously it goes in a place of, special reverence. So we appreciate, Ron. Thanks for being part of the show. Let's go to Alexi in line 2, a regular caller to the Dr. Sky Experience. Good morning. How you doing?
Yes, good morning to the both of you. I find it absolutely incredible, phenomenal, how we can look into the microcosm, the quantum level, and at the other extreme, we could study parts of the universe that are so remote, it's beyond our imagination. Mm-hmm. We can even deliver up images of these things, which were heretofore never known. But what is amazing, I find it even more, even surprising, that we cannot deliver a quart of drinking water to the poorest of the poor of 1.4 billion people on our own home planet.
Yes. Many interesting conversations, Alexi, but it is totally mind-boggling. Doctor, we're almost up against the break, and Alexi, we appreciate you. A quick response from the good doctor.
Yeah, Alexi, we could do that. And it's just we haven't agreed to do it yet. It's quite simple. We could do that.
Well, that's
and
hopefully
we should do that.
Yeah, hopefully as we expand out into the different areas of the solar system, though it'll take us a long time, many of the Earth problems, of course, go right to the front of the caller line here. And exactly, hopefully we can all figure a way to get along. I say it all the time, but obviously my words are not as important as the people who make the decisions, but everybody should be part of the inquiry. I can appreciate you, Doctor. This is so cool, but after this particular break, I'd like to get into a deeper conversation with you, a little bit more about the James Webb Telescope, talking a little bit more about some of the other mysteries of the universe. But my question, if you'd be kind enough to try to answer this, I know it's a tough one, in maybe a minute and a half. Is this true that the concept of working with relativity and what we talk about on that side of the physics equations and the quantum side is the intersection of both trying to get us to the thing called the theory of everything? Is that the way both sides of it are trying to come together?
It's tricky because we don't honestly understand whether and how time and space relate to the quantum things that are going on in it. So should time and space have quantum nature themselves? Are they actually wave phenomena like electrons and light waves? So that's unknown. And so that's a big question for us.
Yeah, it is amazing. I mean, as we talked about before, one of our callers mentioned that Einstein, with his great, incredible genius mind, doing, these, theoretical experiments on the wall, on the chalkboard, trying to come up with what he believed was something else out in the universe, and that spooky action of at a distance concept always rings in my mind because he was onto something, right, Doctor? And he was onto a lot, and I think people should study the things that Einstein had done and given us. Just totally incredible. And you're saying what? That many of these have still been proven correct for the most part. Is that correct?
Yes. As far as we know, relativity that he worked out is correct. Quantum mechanics that he helped start is correct. We just are constantly being surprised by the things that they tell us. So yes, the entanglement is real. It's a very valuable thing that we use technically. And quantum computers can be real. We're not very far along with them, but there's no question that the science is right. What does it mean to people is still puzzling. So we're
much
still
more, ladies and
over the
gentlemen.
Interpretation.
Much more. Sorry to cut you short there, Doctor. Much more as we continue after this next hard break in radio. And ladies and gentlemen, we will be back with you like Janet in Manhattan, Danny in Westchester, and anyone else who would like to call in and talk and ask questions about the mysteries of the universe here on the Dr. Sky Experience. As we say many times, and proud to say it, we like to think of it as theater of the mind. We'll be right back after these important announcements here on Talk Radio 77 WABC.
The Dr. Sky Experience is on the air. 77 WABC. Now, here's Dr. Sky.
I'm Dr. Mario Livio. I'm an astrophysicist at the Space Telescope Science Institute, which runs the scientific program of the Hubble Space Telescope. The institute is in Baltimore, Maryland, and I'm also the author of the book, Is God a Mathematician? And you are listening to the Dr. Sky Show.
Protons give an atom its identity, and electrons its personality. So said author Bill Bryson, one of his great books entitled A Short History of Nearly Everything. We move on at 31 minutes after the hour, and we continue with Dr. John Mather, a NASA scientist still active, ladies and gentlemen, in the exploration of the universe and so much more. Doctor, if you'd be kind enough to explain, you and your co-recipient and Nobel laureates, for this particular story about working with the COBE satellite, the Cosmic Background Explorer, describe to us exactly what you gentlemen identified, and thus the co-recipients of the Nobel Prize in Physics for 2006.
Well, okay. What we wanted to do was measure the primeval heat of the universe. It's still here after all these many, many years. And we wanted to measure the temperature, see if it's got any special features in wavelengths of different colors. And we wanted to make a map to see if it's the same brightness in every direction. So we did that. And when I first showed the measurement of the spectrum, we got a standing ovation from 2,000 astronomers. When we made our map public, we got Stephen Hawking to say that it was the most important scientific discovery of the century, if not of all time. So we knew we'd done something interesting, and it took a team of 1,500 people about to do that. It was still a small satellite as things go, but we launched it in 1989.
So that's amazing. So in my way of interpreting it, see if this is correct, it brought cosmology into the world as a precision science. Is that an accurate statement?
Yes, actually, that's what the Nobel Committee said. And before that, we only had general idea. We had a completely bizarre alternate theory that was pretty popular that was called the steady state theory, and that was wrong, and we proved that. So now the only theory remaining that's good is the expanding universe story, also known as the Big Bang, but that's a rotten name. Yep. So that was the big achievement.
Yeah. I like the way you say that. What would you call it then? If I haven't been listening clearly, and the listeners, if it's not the Big Bang, what would you prefer to call it?
We should call it the expanding universe. The trouble with the Big Bang name is it makes people think it was a firecracker. And
That's exactly
in existing space and time, and it isn't. It's all of space and
that's
everything.
Amazing stuff.
The entire universe is expanding, not just a little piece.
This is very exciting. Let's go to line number 3, if she's still with us, and thank her for her patience. Janet in Manhattan, you're on the air with Dr. John Mather. How you doing?
Oh, hi. Fine, thank you. Doctor, I heard you use the word a couple of times tonight. You used the word information, and I have a feeling that physicists use that word slightly differently from the rest of us. I mean, colloquially, I would say, oh, I have to go to the library and get the information on the new tax law. You know, I'm talking about facts and factoids and things like that. But I know when scientists use that term, it seems to be a little different. Can you define the word information? And I think I remember hearing Dr. Michio Kaku once talking about traveling, space travel, time travel, and he said there was nothing in the law of physics that would prohibit time travel, but you couldn't bring information with you. So I don't know what he meant. I didn't get a chance to ask him, and I'm sure you know, I shouldn't be asking you what somebody else meant, but if you could define a little bit information as physicists use the term.
Well, Janet, you bring up something interesting. I think the good doctor, and he'll speak for himself, was mentioning that the real problem of not going or being able to go faster than the speed of light is that you couldn't bring the information with you. Doctor, Janet brings up some interesting quandaries there with the term information.
Yeah. So she's right. I'm very much in favor of data centers like libraries, and I think we should have as many libraries as possible. And the Wikipedia is my best one these days. I use it all the time. But coming back to information, we do have a mathematical definition in physics that basically says is something a 1 or a 0, and then we count up how many of those bits that it takes to describe a fact. And so that's, we've got a mathematical definition, and how many bits does it take to say something?
Yes. Pretty good. Janet, if you're with us, you get a chance to respond back. Go ahead, please.
No, that explains it somewhat. I appreciate that. Thank you.
Well, Janet, we appreciate you as all the callers here. Let's see if we can complete this round of the caller line. Line number 4, Danny in Westchester. You've been patient. Good morning to you. How are you doing?
Gentlemen, and first, Dr. Sky, your epigones are bench warmers. This is awesome. John, welcome aboard.
Thank you.
I just want to bring this out a little. I just want to stretch this out a little further now. In China, they teach in the school system when the kids are very young, all the way up through high school, college, artificial intelligence. We're really not doing that inside America. I think that is going to be one giant leap for mankind, whoever gets to be the front runner in artificial intelligence. And also many Chinese students, unfortunately, are able to get into our best universities when it becomes technology, whichever ones, the whole roll of the board there. But the thing is, why isn't America leading in this aspect of teaching kids artificial intelligence in schools, coming up with experts, being able to use it to our full benefits? And it's not being used. And why is that? Is it because the Board of Education or the education systems in our country are just totally incompetent? And I believe that's the case. They're incompetent, and they want to teach what they want to teach, even if it's anti-American nonsense.
Well, Danny, you bring up a whole bunch of good points here, a little on the political side, but hey, valuable information. Doctor, if you'd like to respond on that.
Yeah, well, it's certainly well known that China is very direct and pushy in planning for their future, and they recognized a very long time ago that educating the citizens to be engineers and scientists was really important to them. So they have pushed as hard as they could to do that. I wouldn't say I like their political system, but it is the only country in the world that is run by engineers. So engineers plan ahead, and they see what's going to be needed, and they make it happen. So we should have some admiration and respect for that. We should need to accomplish some of those same kind of planning ahead activities here. We should say education is so important for our future that every child should have it. And so there's so many reasons that everyone knows about why it's not happening, so I'm not going to answer that one. I just want to say how important it really is to give every kid an education, and those who want to do it, to give them a science and engineering education.
Well said, Doctor. And Danny, it's interesting, as many people may or may not know, China has a 100-year plan on many of these particular subjects, and I think it would be, very much interesting if the United States and other countries pushed forward a 100-year plan, because that's a lot of time with a lot of goals, and they do seem to be accomplishing so many of them. It'd be nice if we had a specific 100-year plan, and particularly what the good doctor's talking about how to educate people at a young age to move them into the sciences too, and not just that. Appreciate it, Danny. Thanks for your commentary always on the Dr. Sky Experience. This to me is always so fascinating. When we go back to what we said before, and you qualified what I said, cosmology has now been a precision science after this particular Nobel Prize, you and Dr. George Smoot. But it's interesting. There's two complicated topics here, isotropy and anisotropy. And I know the audience may be scratching their head and saying, what the heck are we talking about? But I come to understand, and I hope I'm right, the isotropy, it's uniform in every direction if we're talking about something where the anisotropy is what? Direction dependent. So if you can explain that, it's very deep from our side of the equation, but it has a lot to do with the Nobel Prize that you share.
Yes, indeed. It's basically the question of, is the universe uniform, or does it have hot and cold spots? So we discovered and measured that there are hot and cold spots in the Big Bang material. And so that turns out to be important. Why did Stephen Hawking say that? If those spots were not there, we would not exist. Because what happens is the spots represent density variations, and the places that were just a little more dense than average had enough gravity to stop expanding. So the material in those denser spots turned around and collapsed into galaxies and stars and eventually planets and people. So we're here because of those spots, and that's why Stephen Hawking thought it was so important.
That's totally amazing. And as we shift gears on you, and this is so fascinating, trying to get as many callers on and as many subjects to be addressed, I read a story once that the great Stephen Hawking was talking, of course, after John Wheeler and others before him worked on this whole concept of what black hole dynamics were. Apparently, Stephen Hawking, and if I have this correctly, said that theoretically black holes can leak. And this is interesting because the description was black holes can have hair. Now, to many listening, that may sound like the craziest thing you've ever heard. What kind of hair does a black hole have? But simply, Doctor, is it that black holes are not as constant without anything not escaping as we thought before, that there's the possibility, is what Stephen Hawking talked about, that they have the tendency to what? Leak over time? Is there any accuracy in what I'm saying?
Yeah, apparently so. It's not something that's easy to measure, so we can't really say we've proven it by measurement, but it is a pretty strong prediction from the quantum mechanics and black hole physics. So yes, we think they do. And we think that they have heat radiation that would come out, and they would gradually lose mass and shrink down to finally wink out. And we don't know what happens at that point.
And they're not to alarm our listeners out there. Nobody can prove it. I don't think anybody, even yourself, that black holes can now permeate even smaller versions of these black holes, can permeate what? The vast cosmos, in a sense, not where we look and identify, like, say, the one in the center of our galaxy, this supermassive black hole. Any concept where they might just be able to do what they want, small and grow large, and just roam the universe, theoretically?
Yeah, in fact, that's one of the big open questions. Since it wasn't, dark matter does not seem to be any of the other things that we have thought it might be. What if it could be primordial tiny black holes that are still here from the beginning? And so, and they could still be hard to find, because if they're the right size range, there would be not, we could have missed them, we could have never seen one, and they could still be there. Because
that is incredible.
They're black, which means you can't see them. Things fall in, but they don't come out.
That's
and so
amazing.
You can't see them. You have to detect them indirectly.
And some say, I know not time to discuss it in detail, but just a statement from me and many others, that time theoretically could be an illusion, a total illusion. And we talk more about that all the time when we have great guests like yourself, Doctor, on these many mysteries of the universe. I mean, I just say this from my perspective, and I know you agree, Doctor. Get out to a dark location, experience and breathe in the beauty of the deep of the night. And it's unfortunate that many of us who live in cities, we can take vacations, but I know you and I are brothers in that concept, that there's so much to see, and what a relaxing moment it is for me. And I can't think of it any other way, can you? Other than a relaxing experience. It calms me down, and it makes me think how small we are, and really truly how little we know. What say you?
Well, not only how small we are, but also to remind us that as far as we know, we are the only creatures in the entire universe doing what we're doing, having a conversation on the radio. So we're also special.
That's amazing.
Tiny, insignificant, and very special.
Doctor, we appreciate you. One more segment as we wrap up hour number 2. Sad to say, we wish we could do this for 52,000 hours, but we'd always ask you to come back at your convenience to update us on the latest. We'll be right back with our very special guest, Nobel laureate, Dr. John Mather of NASA. A great experience, and still time. We have a couple of callers on the line, like Max in Manhattan. Stay there if you will. Thank you for your patience. 1-800-848-9222 to the top of the hour. We'll be right back.
The Dr. Sky Experience is on the air. 77 WABC. Now, here's Dr. Sky.
This is Rizwan Virk, author of The Simulation Hypothesis. An MIT computer scientist shows why AI, quantum physics, and Eastern mystics agree we are in a video game. And you're listening to The Dr. Sky Show.
As far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality. A complicated but yet important quote from the late, great Albert Einstein. We move to 46 minutes after the hour. Time may be an illusion, but on this radio show, we do have the restraints. And of course, we welcome the callers. Doctor, I'm going to go to the last of our callers, at least for this hour so far. We welcome Max in Manhattan on line number 1. Thanks for your patience.
Dr. Sky, thank you for taking my call. You had a previous caller call in and ask why China is excelling and so organized, and we, on the other hand, are failing and not keeping up to current trends.
We did, yes.
I might want to recommend if we look at Afghanistan is called the graveyard, nicknamed the graveyard of empires, because when an empire is about to fall, collapse, and change into another government, if for some reason has to be sacrificed in Afghanistan. It happened to the British, it happened to the Russians. Unfortunately, it happened to us, where we were sort of self-sacrificing and hopefully to rise again. This seems to be some sort of military ritual that takes place, and unfortunately, we are being put, the U.S. is being put in a position of falling, sort of like the Bennu bird, and to rise again like the phoenix.
Mm-hmm.
And this is the trend we've been put on. With the Chinese, it's just the opposite. They paid their dues and with communism and lived like slaves for a long time, and now it's their time to rise.
Wow. Powerful stuff, Max. Doctor, I don't know if you want to comment on that, but again, Max has some good points here about how America, in his opinion, I'm reading between the lines, we obviously need to pay attention, not necessarily so we can all go to war, but if you want to comment, Doctor. If not, I want to move forward, but thank you, Max, in Manhattan, for your participation.
Yeah.
Yes, sir.
Yeah, just a couple of things. When we look back at this time from 100 years in the future, we'll say thank you very much for the Chinese investment in renewable energy, because we're going to need it, and we're using it everywhere. We're installing it as fast as we can, and they're making it possible. So that's number one, something to be thankful for. And we can't fault them for doing a good job. We should try to do a good job, too.
Go ahead, Doctor. I'm sorry. Did we lose you?
No. I was just saying we can't fault them for doing a good job.
Yes.
And we should do the best job that we can. So they are a rising power in science, fundamental science. They are wealthy enough to build pretty much anything they want to do. So I expect to see them doing whatever they like in outer space.
Interesting enough. Doctor, we want to end the show with the positivities here, and I appreciate you being with us on the show. How do people get in touch with you? Should they just Google you, John C. Mather, Dr. John C. Mather? Any specific? I know some of the emails are rather lengthy, but do you tell us, how can people get in touch with you if they so desire?
It's probably handy to write to me at my NASA email.
Okay.
John, John, .c, that's my middle initial, .mather, M-A-T-H-E-R, at nasa.gov.
Sounds pretty simple, and we hope that the listeners will follow up with you. But here, I want to give you the floor here, sir. That's very important here for about the next 9 minutes. Your new projects that you're working on. Let's hear about these projects. But thank you so much, and I hope you'd be willing to come back. Is that something you'd consider to do in the future?
Yeah, no, this is fun. I like doing this and being able to talk with our world about the cool things that are happening and what they mean. So what I'm thinking about doing next, I got ideas. So one of the enchanting possibilities is we have big telescopes we're building on the ground. They're bigger and bigger and bigger. And we know how powerful they could be if you could compensate for the turbulent atmosphere above us. When you look across a field, even our own eyes can see shimmering images in the summertime. Well, we have the same problem with telescopes, and if you could get them to be compensated, then you could get sharp images almost as good as they would be in outer space.
Sounds like adaptive optics to me, right? Adaptive optics.
It is. It's called adaptive optics. It was started off in the 70s, and then it was classified because it was military importance. Then it was rediscovered, and now it's available on large telescopes. So my ideas have to do with maximizing the use of that with satellite beacons in space, and even the wildest idea is a orbiting star shade. If you could cast a shadow of a star onto a telescope on the ground from a great distance, you'd be able to see the little planets orbiting around it, and very quickly, in about a minute, you could see them. And so I'm pushing that idea. We're calling it a hybrid observatory for Earth-like exoplanets. So we went from it's wild and crazy to it's actually a pretty reasonable thing to try. So we know what we'd have to build, and if somebody said, here's $1 billion, I think I'd know what to do next.
Sounds great. That's
Still,
amazing.
it's a lot of money, but I think it's possible.
Yes, and some of these gigantic telescopes that they're building, like in the Atacama in Chile, that would be, of course, a great asset to have adaptive optics take away, as I use telescopes all the time, but nothing like those guys. But again, I see the shimmering image, and I don't have the expensive equipment to do adaptive optics. But you're also involved in some other projects, too. I mean, you want to talk about something called the standard light bulb in space, not necessarily what you think. Tell us about that.
Yeah. So, honestly, we don't know how bright the stars really are because we've never been able to launch a standard comparison. So we'd like to take a source that we measure over at the National Institute of Standards of Technology. We say we know exactly how bright it is, and launch it into space and compare it with the stars that we're looking at. So we've never been able to do that. That project is underway. It's being led by Peter Plavchin at the George Mason University here nearby to Washington. So that's coming. And we also have ambitions for other hybrid observatories with orbiting laser beacons in space to do this compensation for the turbulent atmosphere. So I think it's possible. I think it's powerful, and I think we should all do it. And we're going to make it happen if we possibly can.
Amazing. Many times, or many years ago, I should say more accurately, we spent some time at Caltech with Dr. Kip Thorne, as you know him, I'm sure, very personally, theoretical physicist there. And I laugh because in school I had his book, the giant textbook called Gravitation. And I'm always honest with this audience. I brought the book. Yeah, we were doing a documentary, Doctor, and I brought the book, and he said, well, why'd you bring the book? And I said, honestly, I wanted to give you, an opportunity to sign it. He says, well, what grade did you get it? And I said, I got a C+, and I'm being honest with the audience. So he laughed, and he said, well, why would you want me to sign it? I said, you know what? I said, what I want to do with our telescope observation sessions is bring that giant book, which was thick like an old white pages of big cities in the past, so children could step on it, looking into the telescope and be higher and closer to the heavens. And I got the biggest laugh out of him. And that, to me, was a very cool thing. Isn't that interesting, Doctor? What a cute way to introduce your C+, so that you didn't throw me out of the room. But anyway, on a serious note, we got a couple of minutes. He also is a co-participant or a co-recipient as a Nobel laureate for something, I saved it for the end. Even more bizarre stuff, gravitational waves. What in the heck are we talking about?
Yeah, well, if you have a lot of shaking going on, and say, extreme case, two black holes orbiting around each other, they can send out waves of shakiness from gravity that travel at the speed of light across the universe. And Kip Thorne was one of the theorists who said, I know how to calculate that. And there was a team of other people that say, we know how to build the equipment to do that. And it took them about 50 years, but they did it. So they got their Nobel Prize for that, and a tremendously successful thing. And a big surprise for that, they told us something we would never have guessed. It wasn't about gravity, it was about gold. When you look at that gold ring, if you have one, a lot of the gold in our universe came from emerging neutron stars. So neutron stars are about the mass of the sun, and they're all neutrons. And when they merge together, you have a black hole coming out and a flash of heavy elements. So gold is one of the heaviest elements, and it's liberated into space by these collisions. And we found that out from seeing one with the gravity wave detector. So one of the things that they could prompt and say, that's a good reason to give the discovery a Nobel Prize.
So then the last one, and this would take a long time to explain. You, of course, have the chair and the floor. But the obvious thing is gravity is really not simply what we think. It's the warpage of space-time. So when we think of gravity, we must think of it in much more complicated ways. The warpage of space-time, right, Doctor, is gravity.
Yep, yes, exactly. That's a way of describing it accurately mathematically, because it represents the fact that the mass that causes inertia is the same as the mass that causes gravitational force. So it's a mathematical simplification of that story. But it also, the surprise in it is that gravity has a speed. And that's something that people did not know. So Einstein told us that part too.
Wow.
Gravity has a speed.
It's amazing. And we said 670 million miles an hour for the speed of light. So when you get to see somebody, if let's say a police officer stops you and you were speeding, and you could say nicely, and you probably get a second ticket if you said it, well, gee, how fast was I going? And they say, well, you're doing 20 over the speed limit. Well, officer, do you know what the speed of light is in miles per hour? It's 670 million miles an hour. How about give me a break? Well, maybe you'd get a second ticket, but at least that's educating on the road. So there you go. Trying to be funny, but I don't know how well that goes.
Yes. Anyway,
there you go.
And our solar system is so small compared to the distance to the next one. It's just a reminder. We can't get there from here, and they can't get here from there. So we're not in great danger of being invaded or eaten by space invaders.
Yes.
But I'm still disappointed that if there are any, they did not come to visit me.
You're right on that. You're so right on that, Doctor. Again, thank you so much for being part of this experience, and I hope the audience does appreciate your time. We will continue to follow up with you, and any late-breaking information that you can share with the audience, you're our go-to guy in those specific areas as we continue with the Dr. Sky Experience here on Talk Radio 77 WABC. Thank you so much, ladies and gentlemen. A happy Mother's Day to everyone. The subjects of astronomy, space, aviation, and weather, celebrity guests, and stories of American exceptionalism. Doctor, I think we've succeeded, and I'm sure many of our listeners, maybe many, many more out there in the future, we all try to learn something new from every experience in our theater of the mind. Have a good morning and a happy Mother's Day to you and your family. We'll talk soon. Thank you, Dr. John Mather.
And thank you, Dr. Sky.
Appreciate your time, sir. Ladies and gentlemen, that concludes this edition of the Dr. Sky Experience. Stay tuned, because right after this particular show, lighting up the phone lines will be, as always, Another Side of Midnight with Lionel, as he continues to take us through time and space to the early morning hours here on this great radio station. And as I mentioned before, if you look into the nighttime sky, some of the interesting stars that you can see as you look high up into the northeast sky just around sunset, the brilliant star Vega, 25 light years away, part of the story of the interesting movie Contact with Jodie Foster. That's the bright star that's in that. And then high in the southeast, the orange supergiant Arcturus, 37 light years away, a star that opened up the World's Fair in the 1930s with a telescope on Lake Michigan. And literally, they took the light of that star Arcturus and turned on one of the great World's Fairs that were separated by about 37 years apart, the light distance of Arcturus. Again, happy Mother's Day, clear skies, health and happiness, and we'll do it again on the Dr. Sky Experience. And while you're at it, why not download the WABC app? It makes it a lot more convenient. Have a great week.
77 WABC and Bergen Newbridge Medical Center honor the life of legendary broadcaster and our friend, Ernie Anastas.
Hi, it's Ernie Anastas. You know, your thoughts can affect how you feel. Bergen Newbridge Medical Center is the largest hospital in New Jersey, providing comprehensive, equitable, compassionate, and high-quality emergency inpatient and outpatient medical care, plus mental health services and substance use disorder treatment. The Bergen Newbridge team can address your total health needs in one convenient location. Call 201-225-7130 for an appointment or newbridgehealth.org.
Ryan Reynolds here from Mint Mobile. I don't know if you knew this, but anyone can get the same premium wireless for $15 a month plan that I've been enjoying. It's not just for celebrities. So do like I did and have one of your assistant's assistants switch you to Mint Mobile today. I'm told it's super easy to do at mintmobile.com/switch.
Upfront payment of $45 for 3-month plan, equivalent to $15 per month required. Intro rate first 3 months only, then full price plan options available. Taxes and fees extra. See full terms at mintmobile.com.